Hi. Yeah, I'm Brandon. Yeah, I led the iOS and Android team at Kickstarter for like 5.5 years. And I'm here to talk to you about playground-driven development, which is something, most everything in this talk are like ideas that I developed while there. Um, so let's start with what is blank-driven development. There's a lot of these. And honestly, it's probably just mostly marketing. It's kind of like a way of describing a development methodology that makes it seem like very important. And it kind of tends to have a cultish aspect to it. So I would say be skeptical anytime someone's trying to push blank-driven development on you, and like I am right now. Um, you know, I went for this catchier title because I think a lot of people think of playgrounds as more just like scratch work, kind of experimenting with things. And I think it's way more than that, and it can be very important stuff. So what I mean by playground-driven development is that you build your application, spending a large part of your time in playgrounds, in particular the entire view layer. All the view hierarchy and styling and all that stuff can be built just directly in playgrounds. No, not using storyboards or interface builder, or like running in playgrounds constantly. And it's a pretty real like development experience, not just scratch work. So let's start with some examples from what we did at Kickstarter. And if you don't know, the entire code base was open source back in December, so you can run this code and look at these playgrounds and all that. So this is an example. On the right side is a creator dashboard for creators on Kickstarter. They can see like top level stats, how much has been pledged, like a graph showing how well the project is doing, send messages, look at activity, like a whole bunch of stuff. And on the left is like a setup of all types of little data points that you get to tweak so that you can see how it updates in the playground. For example, if you just comment out or uncomment out line 21, you kind of see like the graph moved up a little bit more. I just kind of go back and forth. You see the graph goes up. If I uncomment out the next one, now the graph went above the goal, and the goal line goes away, and you kind of get that little green area to show like how much of the time were you above the goal. If it then drops below the goal line comes back. If it goes back up, it only highlights the part past the last time it went above the goal. And then finally, just something to like see a wild edge case of, at the last moment it gets like hockey stick growth. So this data was like purposely sculpted to kind of show these edge cases so that at any time someone can pull up this playground and start messing with that data. Line 36 controls what project we're looking at. And it's just a hard-coded project. I just created like, I mean, this is a project that actually existed on Kickstarter, but all the data is hard-coded, no API request or anything like that. And so you can change it. I just changed it to a project called Anomalisa. So you can just have some hard-coded data to plug in and see how the interface changes. And then line 40 is the actual language that the device is running in at that moment. So currently it's English, but you can put it in German, you can put it in Spanish, you can put it in French, you can put it in Japanese. Every language that we supported, you could just instantly tweak. All the languages that we supported, we could tweak, which is nice because typically the way you would do this is to go into settings, change your language, and I think that maybe even causes a reloading of iOS, or it does some work, and also it's just kind of a pain. So you could use this to like check out all types of edge cases. Like German is typically 30% longer, and so you want to check your interfaces in that language. And then we created playgrounds for tons of screens. Almost every single screen had its own playground. So like we found it very useful. We pretty much replaced all usage of storyboards. There were storyboards, but it was mostly to create view hierarchy and constraints and stuff like that. But the actual styling, we would do all that work in playgrounds. You don't get this for free typically. You gotta do a little bit of work. So some things you need to do. Your view needs to be able to live in isolation. You need to be able to instantiate it without having like all types of work to be done in order to like get to the point where you can instantiate it. You need to be able to just like create it in order to like throw it in the playground. And that like the best way to do that is if it was modeled in such a way that you could just hand it some data that represents like what that controller can show, and then the controller just takes that data and does its job. You need to have no side effects in these controllers. Side effects being things like making API requests, database requests, tracking analytics, all that stuff needs to be controlled and isolated. The main reason being that these playgrounds are going to run constantly. Like you're going to be like making edits and it's constantly running. You don't want to be like firing off dozens of API requests or accidentally tracking analytics that's going to muddy the data. And also, you want to be able to control what the results are from those things so that you can see what your interface looks like when your API returns a particular type of data or it maybe errors and you want to like check out the state of the interface. Popular way to handle this is dependency injection, but there's other ways too. So when you drag a playground into a Xcode project or a workspace, it instantly gets access to all the frameworks that are defined in that project or workspace, which is nice. You can just go into the playground and import anything that's exposed there. It does not get access to anything in the application target. I don't know if there's a technical reason for this, but it doesn't get anything. So what you have to do is you take all your application code and you move it into a framework, basically only leaving the app delegate inside your application target, and then the app delegate imports like your app framework and can hand off to the root controller or whatever. But so you got to move everything to a dedicated framework, and then you can import that into a playground and start using it. And then, so once you move everything into an additional framework, it all of a sudden becomes important to deal with bundles. That was not something I ever really had to think about. I think I just always used bundle.main, and it was pretty much, everything was always good for the most part. But now that's not the case. Your asset catalog, or if you don't use asset catalogs, whatever assets you use, your storyboards, your zibs, all that stuff is going to be in a whole different target. And it's got its own little bundle. So you like a lot of things that you typically don't think about needing to specify a bundle, all of a sudden need to. So if you try to create a UI image, you can't just use the name because it's going to look in the main bundle. You have to specify the bundle. If you try to load up a storyboard programmatically, you have to specify the bundle. It's all possible and it's all simple, but it's just something that maybe you don't typically think about. Some pros of doing this method. You get to test things in isolation. To be able to bring up any screen in your entire app and have it be a fully functioning version of that screen without, like, so for example, that creator dashboard. In order to even see that screen in the Kickstarter app, you have to be logged in, and you have to be logged in as a creator. And I'm someone who has never created a Kickstarter project, so up until this point, if I wanted to test, I ran on the simulator, and I asked one of my colleagues who had done a Kickstarter project to log in as themselves for me on my simulator, and I could test these things. So when you do all those requirements, you get to fully isolate all of that away so that you can just provide the data. And I just got to provide raw data of what project and what stats, and then I got that screen. The playgrounds kind of become living documentation and a style guide for your entire app. Anyone can look at this stuff. You can even have designers and PMs clone the repo, hit Command B to get everything built, and they can just like poke around playgrounds to see things. So I kind of think of like tests as capturing like very precise and nuanced logical requirements you have in your app, and the playgrounds are just like broad strokes of visual styles and states that screens can be in. There's a lot of things that define, like a lot of kind of global properties that define a screen. Things like size classes, like regular and compact. There's the preferred content size that people can change in settings. There's even, is the layout direction left to right or right to left and all that stuff. Typically, all that is controlled deep in iOS settings. If you want to kind of tweak those things, you either run on completely different devices, like iPad or iPhone, or you have to go in and like change your preferred content size or accessibility settings. It's possible in a playground to fully control all those things. And you can just live change right in the playground and bring up the screen on an iPad versus an iPhone, left to right versus right to left, all those things. It works for all the platforms that we're used to, but increasingly I'm finding uses for playgrounds that are kind of surprising. And I'm going to show one of those later. And all the Apple tech, every year when WWDC comes around, every new thing that they announce is available in a playground. Asset catalogs, storyboards, zibs, prototype cells. Like, you're not getting yourself into a weird situation. You're not investing in a weird technology. Like, you'll always have access to those things. Cons, well, stability of playgrounds. It is like a constant roller coaster. In fact, Xcode 8.0 through 8.2, they just simply didn't work. And I was at Kickstarter at that time, and we just like stopped using playgrounds. They just didn't work anymore for some reason. 8.3, like they came back alive, and Xcode 9 has gotten a lot better. But yeah, it's like a little bit scary how bad the stability can be sometimes. If the stability was really good, if it gets there, I would have no problem selling this to you as like a magical UI, wonderful land to live in. It's because it can be magical sometimes. You kind of have to invest a little bit in getting your views in shape to take advantage of this. I think though that eventually produces better code in general, whether you're using playgrounds or not, like the ability to isolate side effects and test in isolation. But maybe you can't make that investment right now, and it could be significant. So then with that foundation, I'm going to do some live demoing. Okay. So I made this app, or this controller in the playground. I have a bunch of stuff collapsed because I don't want to like overwhelm you with things that are in there, but let's dissect it for a moment. So the app is a counter app in which you can hit plus and minus to increase the counter. In order to make it a little bit more interesting, what I have is every time you hit it, it actually makes an API request to a service called Wolfram Alpha, which is like a large computing platform API, and asks whether that number is prime, a prime number. So very simple, but at least it's got some of the ingredients that make an app complex. I also have a very large number I can plug in here so this number would be pretty difficult to check if it was prime if we actually made the prime checking algorithm directly in Swift. And so I can see that it's finding primes and things like that. So it works. What is in this hidden thing is the architecture of the app that I was kind of describing before, of needing to isolate side effects and things like that. I've implemented it as like a very basic kind of Elm-like, Redux-like, state action reducer store kind of system. But use whatever you want to use as long as you're kind of controlling those side effects. This is just what I did because I can put it like in a small code snippet. Also, all this will be on a GitHub repo, so you can check it out in detail. The store is the thing that the controller communicates with to send all the user actions to it. It's doing the computations in there, and then it sends back out the state of the app. And then view did load just creates a whole bunch of UI elements, labels, buttons, all that stuff, sets up constraints, creates the view hierarchy, and then we have a couple of taps here. So some fun things. Let's start like actually developing a few things in here. For one thing, I have an image in the asset catalog that allows me to put in the logo of the conference. So here is a whole bunch of UI code, but right here I've got an image view. And I can do image view.image equals UI image named, I forget what. So let's start with this one. It's FrenchKit hyphen logo. This isn't going to load the image because this is going to use the default bundle, which is the bundle of the playground. So I gotta be a little bit more specific, and I gotta specify the bundle. And there's a few ways we can do this. So first, there's a different initializer that allows you to specify the bundle. There's a couple of initializers on bundle that you can use in order to pinpoint the bundle. You could use the bundle identifier. Like every framework has an info plist, and that info plist is a bundle identifier. You could just use that. That's a little bit fragile because that bundle identifier can change, and typically I don't think the bundle identifier means much in a framework, so maybe one day you go change it and you break everything. There's another one in which if you just pick a class that lives in that framework, you can just like pin it to the bundle that's associated with that class. And I just threw a class in there, like you would pick one that you actually use, like I just created one just to pin it, and there, I've now pinned this bundle to that framework. And then also important, the other initializer doesn't give you this, but you get to specify a trait collection so you can have it be adaptive based on, I don't know, scale and gamut and all that stuff. So now if I run this, I think the logo should pop in. Oh. So I got to import that framework. Okay, so we get that logo. So then the next cool thing is that all of the like size classes and all that stuff is controlled by something called trait environments and trait collections. And there's a method on controllers that allows you to override trait environment, which is typically just provided by the system based on system settings. You can override it for a child like subcontroller. And so I created a little helper that I use in all my playgrounds that kind of automates that entire thing. So it takes a couple arguments. You give it the controller that you want to wrap in a parent controller so that you can control its traits. I have a little enum here of different devices that you could use. So we could start with a 4.7-inch iPhone. You can choose an orientation, so I'll just choose portrait. And then you can specify additional traits to override. And so for right now, I'm going to pick the one that allows you to give an array of traits and just provide an empty array for right now. And we'll fill that in with some stuff in a moment. So nothing has really changed now except that we just wrapped our controller in a parent controller. But now we get to throw on traits. Like I can throw on the trait of where is it? This one here. So I can override the user settings of what they say their preferred content size is, and I can provide it, say, extra large. Did that get bigger? I wasn't paying attention. Okay, yeah, it got bigger. And then it showed a problem I have in which the title got truncated, and so I can just like quickly fix that. I say title labeled number of lines, 0. And now it word wrapped. And there's all types of interesting trait environment things that you can override. For example, probably someday we're going to get dark mode on iOS. Apple TV already has it, and that's a trait environment. So in a playground, you'd be able to swap between dark mode and non-dark mode and get to see all your screens, like how they adapt to that. Even the layout direction is controlled by this. So I can see what happens when I go right to left. And now because auto layout handles all this for you, you pin to leading and trailing, and then they know how to flip that when you go from left to right and right to left. The only thing that is direction dependent in this interface is the plus and minus buttons. They're just gonna swap if I go right to left. So plus and minus swaps. If this was a more interesting interface, you would see more things. If I had a left justified label, it would have gone to right justified. So this is interesting. This is being able to like really just tweak and poke around all this stuff like on the fly. And then when you've like done the first prototype of your interface, you go and move it into your app framework. And so I've already got it here, a class controller in my app framework. That's very small, but there's a directory structure there that has an app framework. And so once I do that, I can just delete all this stuff and then work off of app framework dot controller. I don't even need to specify that, but. So now this is loading the one that's in that framework. And so if I went in and changed something, like I changed the background color from a nice red to a very harsh red, I just Command B to build. I could switch over, and the playground runs. And I don't know if you could really pick up, but now it's just like a harsh FF0000 red. And then that's the flow after that initial point, is you make your changes in the app framework, Command B, switch over. It's faster than a simulator. It's nicer than a storyboard because you're dealing with actual code. You can have like an actual style guide of code. For example, I had a variable called grid saved in the view did load, which was set at 6, which is like the grid units I was working. So every single measurement in the entire interface was a multiple of like this grid unit. And so I get to like immediately change it to 8 if all of a sudden I wanted to see what happens if I'm working on an 8-point grid. Like you just can't beat having code to mess with rather than like an interface between you and the code. And then things got like really interesting. So I did all that stuff. I left Kickstarter like in June, and then I started doing like consulting work for like, to pay the bills. But then I started working on a side project doing some server-side Swift. And I got pretty deep into that, and I started missing like this playground world. So I wanted to see like how do playgrounds fit into server-side Swift. So in server-side Swift, there's kind of 2 different worlds that you need to think about. There's the one world which is doing a lot of low-level stuff, like HTTP parsing, SSL certificates, sockets, and all the stuff that I know very little about. But eventually, you get a request. And it's like URL request from Foundation. As a URL, it's got a method like get or post. It's got headers and post body and all these things. So you get it, and now it's your job to produce a response, like data to send back to the browser, response headers, and all that stuff. So that's the world in which like you do most of your development, and that world has nothing to do with a server actually running. That's just create a request, pipe it through the site that does the routing and the database requests and all that stuff, and then you get like a body back. And that's what has happened here. I just created a request. This site middleware is the thing that does the routing and does all the like computation to produce HTML. I pluck the response out of the thing I get back, and then I just feed it into a WK web view. This is just like a WK web view sitting over here. And it's like a full website. Like you can, you know, mess with it. You can't like click on links and go to other places because you're just looking at like something in isolation. But you can do all types of fun stuff. So if I switch over to that site middleware, now looks like weird stuff with operators. Like, don't worry about that. Like, that's just me doing weird stuff. But you can kind of see what's happening. I've got middleware that requires HTTPS. What that means is if I try doing a non-secure scheme, a redirect happens. I get a 301 moved permanently to HTTPS. And I get to test that like here. I didn't need to set up SSL on my local machine, which sometimes is difficult. Like all I want to know is that when a request comes in and it's not HTTPS, I got a 301 redirect. This redirect related domains allows me to, so I'll put the S back on. If I had a non-canonical version, like without www, I want to redirect that back to the www. So again, I got a 301 moved permanently to www. And I can even throw on like other middleware. So basic auth is like, well, it's basic. It's you just can provide a simple username and password with the request, and it will allow you to tap into that and authenticate. So if I build this, I've just now added basic auth to the entire site. So now if I run this, I should get an authentication error. Like I have to authenticate. Well, how do you do that? It's a header. So if you go to all headers, you can open up a dictionary. It's an authorization header. It starts with basic. You give the username : password, and then you turn it into data, and then you base64 it. Now if I run this, I've provided the credentials. I get redirected. So provide the canonical URL. Got past the authorization, and I got into the site. And then there's other, like you could test other routes. Like when you sign up in this page, there's a little sign up form here. You get redirected back to a URL that has a success equals true. So I could just put that in and see what happens. I could also just see what happens when you actually do try to sign up. And to do that, it means the request method is a post, and the data you send to it is, the body is a form encoded. You say email equal, say hello@pointfree.co. Turn that into data. Run that. So this is the router doing its job, where I tried to do a post to the home page. That wasn't the right route. It's actually, not launch route, launch sign up. So now what this is saying is that we get a 302, which is a soft redirect, not a permanent redirect, saying that we found this, and now like go over to back to the home page with the success equals true. Not hitting the database, not doing any side effects, in total isolation. In the browser world, when you do that post, if you had an error and you try to refresh, you get that error that says, well, do you want to post again? Like you had done a post before, and now you're in this like weird intermediate state. Do you really want to actually submit that form again? And you maybe go back to the previous thing, fill out the form again and post. But also the browser, it's kind of like a storyboard in that it's an interface between you and just the data. Like I want to be able to sculpt some data, send it through the middleware, and see what comes out the other end. There's also like Postman and curl and all those things, but like it's hard to beat just having Swift here and like messing with Swift. So this has been interesting. I've been like making full web pages in Playgrounds. So once you go down this route, if you like found this interesting and you start doing it, I'll just give 2 things that you should try after. One is screenshot testing. Once you've isolated your views so that you can load them up in Playgrounds, there's nothing stopping you from using something like Facebook snapshot test case or something. You take a screenshot, you load up your view in a unit test, you take a screenshot, it's committed to the repo, and then in the future you can do like refactorings or style guide changes and either prove that not a single pixel on the image changed, or if something did change, to verify that that was indeed the correct change. There's a story from Kickstarter where we did a massive style guide update, changing colors and everything like that. And for the most part, it was okay. But there was one single screen, and it was on the creator dashboard. At the very bottom, there was a graph whose title completely clashed with the background. It just kind of became faded. And it was because like we just had a weird color there and we needed to update it. Like that's kind of a bug that would have gone unnoticed for a long time or maybe never brought up. But like it was just easy to just kind of click through a bunch of image diffs and see what changed. And then also, this is something I've never even actually been able to do successfully, but I know it's possible. I know some open source projects do it. But if you have CI set up, you should have the Playgrounds compiling with CI because these Playgrounds become so important, documentation, living style guide. Like it would be a bummer to load one up, months later, and then you're getting compile errors, like APIs changed, or who knows what. Like it should be a part of the CI process to be compiling these. And that's it. And so I think it's interesting stuff. I think it's better than storyboards and better than running the simulator. And it's great for styling views in isolation. And that's where the code will be eventually, but it's not there right now. Thanks.
Thank you. Thank you, Brandon. Okay, you
Brandon.
can come with us. We're going to sit there. So if I understand well, before I was using Playgrounds just to make some UI stuff, and now I can really use my app and try to play with my real my real code. That's really interesting. But there's one thing that we've all experienced is Playgrounds crashes a lot, or sometimes it just it doesn't respond anymore. So do you have experienced that? Do you are blocked by that a lot?
Yeah. It does happen, and it's annoying. It's nothing that an Xcode quit and restart won't fix, but that's also not ideal. I find that they become more stable once you've moved all the code into your app framework, and then you're just instantiating the controller there and providing different data. Like things become way more stable there because then the Playground code is quite small because all your real code is over in the app framework. And then hopefully Playgrounds just continue to get better. Like I don't think it's a bad investment like going into these things because clearly Apple wants Playgrounds to get better. So that's all, yeah.
Got another question from the audience. Is that how you manage locales or languages on Playgrounds? We've seen you did something with locale.
So everything that's translation-based goes through eventually NS localized string. In there, you get to specify language bundles. And so if you just provide like a helper function before that, where you could just maybe create an enum of all the languages you support, and then a little bit of code to translate that into the path to actual lproj file, or I forget the name of it, but the actual bundle that holds the strings. Then you get to change languages on the fly anytime you want.
But be honest, like we've seen that you have some helpers to do that. Mm-hmm. Be honest with us. Like, do you have a lot of code to add yourself to be able to achieve the goal that what you showed us today?
It is not a lot of code. It is interesting way of controlling these side effects. Like a language is a side effect that is happening, and if you don't control it,
Yeah,
then you
fair
can't
enough.
do anything. So you have to have proper dependencies that allow you to control that. Again, the Kickstarter code base is open source, and I've given talks about this
Okay.
before. Ask me, and I can
And
give you more information.
just a last quick question, because we don't have much time, but one word about that. If you ask some questions through Twitter and we don't ask them on stage, we'll ask the speaker to try to answer those questions through Twitter. Just about the speed, like sometimes it's a bit slow. Do you have some tips to accelerate the build and run process
No.
of Playgrounds? Ah, okay. Just waiting for Xcode 9.
Yeah,
Okay.
Xcode 9, it get better in Xcode 9 for
Okay.
sure. But yeah, it's,
Nice.
Yeah.
That was a quick question.
I would say it's still faster than running in a simulator, navigating to the screen and doing all that. So it's still faster than that. It's just not as blazingly fast as you would hope with a playground.
Yes. So thank you very much.